Students, welcome to Python programming class, lecture 13. We are learning unit 2 part 3, fruitful functions. The syllabus of fruitful functions: return values, incremental development, nested functions, Boolean functions, more recursion, and checking times. The first three topics are completed in previous lecture. What are the return values? What is the use of return? What is meant by incremental development? And how to use nested functions. Right? Now, coming to the next three topics: Boolean functions, more recursion, checking times. These three topics we will learn today in lecture 30. Let's start the lecture. Coming to the first one, Boolean functions. What is meant by Boolean functions? So already we know that Boolean values are either true or false, right? 0 or 1, like that. So Boolean functions means here the functions, you define any functions, all those functions return Boolean values. That means the function will return either true or false. Why we are using Boolean function means for testing purpose. So if the statement is correct or not, how to test? It is not possible to test entire code completely after development. Let's take one example. So here you are defining a function is divisible. Is underscore divisible is one function. So how many arguments here? Two arguments, x and y. What is the main purpose of this function is if x percentile y. So if the remainder, right, if the modulus value is 0, so it will return true because it is divisible by x is divisible by y, right? Or else if it is not equal to 0, so it returns false because x is not divisible by y. So like that, here you are testing x and y are divisible or not, right? Same example will return like this. Same, we are defining the function is underscore divisible with two arguments x comma y. Here you are using if condition and else statement and else statement. Without if and else, you can directly return if it is true. X percentage y equal to 0 means if it is 0, it will return. Otherwise, it won't return any value. That's the concept of Boolean functions. Now coming to the second one, more recursion. So we need to take one example, factorial, right? Now see here we are defining a function factorial, right, of argument n. If the argument happens to be 0, so that means if n equal to 0, right, so what we have to return 1, right? So if n equal to 0, it will return 1. Here same, defining factorial of n. If n equal to 0, it will return n. Or else, if n is not equal to 0, what you have to print? So take one variable recurse, right? So recurse is factorial of n minus 1, right? Before going to that, I will give one example. Suppose find factorial of 4 factorial. So it is also equal to, how can you write? 4 into 3 factorial. 4 factorial is equal to 4 into 3 factorial. That's why here recurse is factorial of n minus 1. So n minus 1 means 3 factorial. So result is n into recurse. That means if n equal to 4 means it is n value. It is n value into n minus 1 is 3. So this is n minus 1 factorial. Right? So you are calling the function once again here. So 4 factorial is 4 into 3 factorial, right? It can be written as 4 into 3 into 2 factorial. It will be same. Similarly, 4 into 3 into 2 into 1 factorial, right? Like that we will calculate it. So next 4 into 3 into 2 into 1 into 0 factorial. 0 means what it will return? 1. So finally the answer is 4 into 3 into 2 into 1. So that means 24. 24 is the result, right? So like that you will calculate the factorial, right? So finally you are returning result. So the result is this, right? Let's check the same example in Jupyter Notebook. This is the example program of factorial. So let's run the program here and then call the function factorial of 4. Run it. You will get 24, right? So here, suppose take n equal to 1. Take 1. If n equal to 1, it will return 1, right? Take n equal to minus 1. What it will display, right? So after some time you will get error maximum recursion depth exceeded in comparison. So factorial is only for integer values, not negative numbers. So and also it is not available in floating values, not applicable to floating values. So factorial of 1.5. Yes, for factorial also you will get same maximum recursion depth exceeded in comparison. That's why factorial is not possible for negative values and fractions. That means floating values, right? That's why we need to check the types. So that's the concept of more recursion. Now coming to the next one, checking types. So here I am taking another example. The example is Fibonacci value, not series, Fibonacci value of n. If n equal to 0, it will return 0. If n equal to 1, it will return 1, right? So other than 0 and 1, so what it will return? Fibonacci of n minus 1 plus Fibonacci of n minus 2. Check the example in Jupyter Notebook. So this is the example of Fibonacci number. Here, this is the function program. So run the code and call the function. So I am calling the function for 6, Fibonacci of 6. So you will get 8. Okay. So Fibonacci of 1. So what it will display? 1. So Fibonacci of 0. So it will display 0. So here I am giving 1.5. You got the error. So what is the error? Maximum recursion depth exceeded in comparison. Similarly, you will get same error for negative values. So minus 1. So give that. Yes. For negative numbers also you got the error maximum recursion depth exceeded. So to avoid that problem, right? To avoid that maximum limit problem, we are using is instance to verify the argument if it is positive value, negative value, or any other thing, right? So here same example in different way, define factorial of n, right? So here I am using is instance, but I am writing as not is instance. That means if not is instance, so if n is not an integer value, if n is not an integer value, so what you have to print? Factorial is only defined for integers. So only for integers you are displaying the factorial value. It will return none. If it is less than 0, else if less than 0 means that is a negative number. So factorial is not defined for negative number. Here also you will get none. If it is 0, you will get 1, right? Or else you will get n into factorial of n minus 1. So this is the result, return, right? Let's check the example in Jupyter notebook. Let's define the function factorial. Define factorial of n, right? So first you need to check the n value is instance of integer value or not. So if not is instance of n comma integer. So if n is not integer value, what you have to print? Print of factorial is only for integer values. Integer values. Plus return. Return. What do you have to return? 0. Right? Run the code. Now call the function factorial of 6. Run the code. Right? So here you are giving factorial of 6. 6 is a instance of n. Right? Instance of integer. That's why there is no output. Give 1.5. Run the code. So check the result. Factorial is only for integer values. So what you have to return here? 0. Right? Now give else if statement. Else if n is less than 0. If n is less than 0, what do you have to print? Print factorial is only for positive values. Right? Run the code. Give negative number -1. So see here, factorial is only for positive values. Else if another one, n is equal to 0. Equal to 0. So what we have to return? Return 1. Run the code. Give 0. So return 1. So 3 conditions completed. So factorial of 5.5 gives it is only for integer values. Factorial of -5 gives factorial is only for positive values. Now final else statement. Else, right? So what do you have to print? What do you have to return? Return n into factorial of n minus 1, right? So that is you have to return. Run the code. Yes, 120. So take 4, factorial of 4, 24, like that, factorial of 3, 6, like that, you will get factorial. So here, by using incremental development, you are checking the types. First, you are checking whether it is an integer or not. Second, you are checking whether it is a positive value or negative value. Finally, you are displaying the result, right? So here you are checking is instance of integer. Here you are checking less than 0 or not. If it is equal to 0, so totally 4 conditions, right? That is the concept of checking types. So that's the today's lecture, Boolean functions, more recursion and checking types. We will meet in the next lecture. Thank you.